So in the previous class, we were discussing about the try catch block. Is the try catch block clear? Like the other day, like you people were facing issues that like you didn't understand the clear cut concept behind it. Now did you understand it, or should I again repeat it?
Yeah, we understood.
You understood, everyone? I think Kushal is new today. Hi, Kushal.
Hello.
Yeah.
Hey.
Are you new to Java, or do you have any are you familiar with Java concepts and everything?
Um, I worked as a developer for a couple of years in JavaScript, not in Java,
Okay.
and I am looking for a full stack or like React JS focused role. So I do have some experiences. At least I can talk about like the concepts at least. Right now I have not done a lot of programming in my masters because my major was completely different. So I'm out
Okay.
of touch, but I can
Right.
talk about stuff and I think.
Okay. So the React and front-end frameworks concepts will be starting next week. So
Oh,
this,
okay.
yeah. So this week we are not whatever we discussed, that is advanced Java. So we're going to close advanced Java today, and from tomorrow we're going to start Spring Boot.
Oh, okay.
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 Yeah.
Yeah, thank you.
Problem. Yeah. So after this, you have now um, uh, till date whatever we have discussed. Um, let's say if you're catching an exception, right? You're catching an array index out of one exception. What that is doing, it will print your exception index 5 out of bounds for length 5. So if your class is throwing some exception, this exception will like predefined has some message in it. That is index 5 out of bounds for length of 5. Like it is trying to tell you something. Tomorrow, uh, because you'll be building the application, you are the sole owner of your application, so you need to have custom exceptions. So whenever an exception is thrown, all developers need to know, okay, what is exception, and what are we going to handle. So you have something called as user defined exception. So if you write an user defined exception, and you need to mandatorily extend the exception class, because if you see your exception hierarchy, each and every exception class will extend the exception class. So if you want to write your own exceptions within your Java source code, create your own name, extend it to the exception class. And within, I just created a constructor here, and I'm printing that this is my own exception. So if I try to run some, now I have a main method here. And I'll get this. This is my own exception. So if you're trying to catch array index out of one exception, it will tell you, okay, the index value is something, and you're trying to fetch something. So I'm throwing an exception. If you try to throw null pointer exception, that means, okay, you're trying to perform some operation on a null value, which is not even possible. Hence, I'm throwing a null pointer exception. That's the meaning. If you're getting an arithmetic exception for, let's say, divide by 0, it'll tell you a meaningful message. You're trying to divide a number by 0, which is not possible. Hence, I'm throwing an exception. Similarly, tomorrow you'll be working on applications which are custom made and custom designed by you people only. Because yeah, because these applications take something like, let's say, take your HDFC Bank or Bank of America. HDFC Bank website is completely different from your Bank of America website. So it has its own custom code. BOFA will have its own custom code. So it has its own transaction. It has its own transactions. So if you see your ATMs, and just take a simple ATM, you'll get error codes there. Okay, so and so is the error code, and that will be shown to you in the back end. Based on the error code, people will be writing, okay, if this is the error code, something has happened. That is their own exception hierarchy. Similarly, when you're writing something, you'll put it here. Like in place of exception, you'll put some if blocks. Okay, if code is something, this is the exception. If code is something, this is the exception. So you are writing your own exceptions, custom exceptions. And I'll tell you what is the throw keyword and what are throws keywords. And based on it, you are going to throw your own exception, user defined exception. Is this clear? Why should we write custom defined exceptions? Because tomorrow in your source code, everywhere you'll find your own your own source code's exceptions only.
So
Like,
it says throw new, right? Throw new keyword.
yes, yes, yes.
So trying that logic, it throws. If
Okay.
not,
Yeah, okay. Just a minute then. Just a minute, I'll tell you. So in the next slide, you have some I'll get back to the custom defined exceptions. I'll tell you what does a throw and a throws keyword mean. So Java throw keyword is used to throw an exception explicitly in the code, inside the function or a block of code. So now if we write a simple, let me say try catch. So if you take here and I print something called as gender.length, okay? This is in try block. This whole code is in try block, and I'm trying to calculate gender.length, but my gender is equal to null here. So if I perform any operation on a null value, I know that I'll get a null pointer exception, but I don't want to throw it here. That's why I'm catching it here using a catch block, catch arithmetic exception if it is thrown, else catch array index out of bounds if it is thrown, else if whatever exception if this line is throwing doesn't match the catch block, simply throw the main exception. So this is my meaning. Now
yeah, if the gender.length if doesn't tally with any of the catch, then
yeah,
then we need to keep the main exception, the
main
catch
exception,
exception.
the main exception E.
Yeah.
That is fine, right? Okay. Let's now there will be some some cases. Now what will happen after throwing the exception here? This piece of line will be executed, right? The rest of the code.
Yes.
So this is executed now. But I have something called as a throw keyword. Throw new.
So it is also the reserved keyword, Java reserved keyword.
Yeah. Throw and throws.
Yes, throw and throws. Yeah.
Yeah. Now see the values. So it is straight away throwing the exception. Null pointer exception.
No, right? No, we are getting the same output only. Parent exception.
After getting the see now you are in try block.
Yeah.
Let me take it this way. Now I have something this one. Let me put as null pointer. Now I just throwed my exception here.
Okay, 1 second. Let me throw the exception. Okay.
Okay, but this exception is not in the catch block.
Yes.
That's why my parent exception. What is my parent exception? E.
E.
That is called here.
Okay.
So this line is not printed. Sorry, this is not printed. But what is my user defined exception telling me?
This is user defined exception.
Yeah,
This
it
is
started printing it, right? Yeah,
okay.
that's what is printing. Now, if you see here also,
It is just inheriting.
yes, extends means it's inheritance, right? Because all your classes should extend your main exception class. That is
Yeah.
for sure. So I'm straight away like I know that okay, this will throw null pointer exception. That I know. So I'll straight away use a throw keyword and throw this exception. And here let me put a new catch block.
So you mean to say after we keep throw new null pointer exception, the next two catch statements are dummy statements. I mean,
You cannot call them as dummy. Now, here in my case, I have only I have only one scope of an exception, that is null pointer exception.
yes.
Tomorrow you can have any exceptions there, right? Like within 3 lines of code, the first one can be arithmetic exception, the second one can be array index out of bounds also, right?
Yes, we can keep,
Yeah,
but we can keep. But in this situation, as we mentioned throw keyword and null pointer exception, we know, right? But there is no use of these two catch statements.
Yeah.
Okay. Yeah.
I'm just telling you the use of a throw keyword.
Okay.
We are only throwing it. Meaning I'm only forcing my application, okay, in case of this one, please throw it.
Because of this keyword, it can save space also, right?
It's space meaning?
I mean,
Space?
we don't need to write more number of code, and readability will be more easy.
Not in that way. Not in that way. I'll tell you it. See, you can use it in this way. If gender not equal to null, else so this is the best way of writing it. Control X, Control V. So let's say you have some value instead of null. Simply do a null check. If it is null, you only throw a null pointer exception. Else do something.
Yeah.
So null pointer here, like that's not the exact case for you. Like here, when you're doing your like live industrial coding, right? Then you can make use of this. Do some quick checks and throw your own custom exceptions there. That's why I kept the throw keyword here. Or use your own custom logic, and based on your custom logic, throw the exception.
Okay.
Yeah, that's the meaning of throw keyword. If you want to explicitly throw an exception within your source code, simply use a Java throw keyword. And there are codes. Now, you have two keywords. One is throw and one is throws. So Java throws keyword is used in the method signature to declare an exception which might be thrown by a function while the execution of code. So did you understand the throw keyword concept? You're throwing the code. Everyone? I can put it in the chat box. Yes, done. Now the meaning of throws is yeah. So this is a very important and a very good concept. Like if you try to use this type of coding, it's the cleanest way of writing. So I'll tell you what is the meaning. Now just see this. This is a public method, static void. You have the method name, you have arguments, and you have something called as throws IO exception. Throws. So again, read the statement now. Java throws keyword is used in the method signature. In the method signature to declare an exception which might be thrown by the function. So you don't know whether the it will throw or not. It might throw, it might not throw. So if you have that way, then you'll use something called as IO exception. So everything will be coming under this one: IO, SQL, and class not found and runtime exceptions. So IO, SQL exception, and class not found exception. So these three classes. You can make use of the throws keyword. So why do you want to use it is here I'm making use of the file java.nio.file.files package. Okay, so files is one package which will allow me to read and write files to my local system, to any system. Suppose I have a text document within my local PC, and if I want to read that content from the text document, what will I do? I'll simply create a file object, and I'll give the path of my file within my local system. And based on that, it will take the file, it will read the contents, and it will give it to me. In this process, if the file is not found, so I'm giving file as an input to my Java class. Suppose the file is not found, it will simply throw an IO exception, input output exception. If I don't, like, let's say if I don't use a throw keyword, you see the exceptions there. It will tell you unhandled type of exception. You're trying to handle you're trying to handle something which is out of your Java class scope. So simply put an exception. You can either use a catch block here or use a throws declaration. You have two fixes. So if you add throws declaration, it will throw. I'll tell you it. See.
Access denied exception.
Yeah, some exception. Because I tried to provide a file which doesn't even exist for me. Now let's say so you just copy the path, the file absolute path. You put it as this one. Now if you see, initially I gave text only on test 1. If I open test 2, I got the text here. So what I did, okay, just let me tell you one again. This is changed in test 1. Let me put this in test 2. You have, let me wipe out the content. And now let me run it as Java application, refresh. Whatever data is present in test 1, it is copied to test 2. So this is my operation, copying data from one file to another file. Now in this now my Java application is here, like within this source directory. My files are located in somewhere directly. Like they're not even they're not even linked with my Java source code. So since I am working with some external files, I need to tell my Java application that, okay, in the event of your file not found, simply throw this exception. Using a throws keyword, simply throws the IO exception. So let me put test now. Now obviously this file will not be found for it. See the exception. Hey. Oh, this is a buffered reader writer, right? Okay, it's simply writing it. Let me put test 1. Let's test. No. Test. Okay. It through. No such file exception. So in turn, this will be coming in from your Java IO exception only. From the input output exception, you're going to get this file, no such file exception. And did you understand the difference between a throw keyword and a throws keyword? Throw is when you explicitly want to throw some exception, you use the throw keyword. And if you use a throws keyword, it is the method which will be throwing the exception. Clear?
Yes.
Okay. So now whatever code which are seeing here, if you, the main difference is from your try and from your try from your previous try block and this try block. Just take a look at this. This is your syntax, right? Try some piece of code. If there's any exception, catch the exception, and finally close the whatever is open here. You simply close it. This is the exact syntax, right? But if you see here, you only have these 3 lines of code.
Yes.
Correct? Meaning, whatever which we are working now is called as try with resources. Try with resources. So you'll have a try keyword, and within your open close brackets, you'll provide something called as a resource. So buffered reader, this is called as a resource. This is same as a scanner class. You know the scanner, right? Scanner equal to new scanner, scanner dot read something. So what will you do in the last? You'll write something called as scanner dot close in the final statement. Correct? Here, scanner.
If a user need to provide an input for a console, yeah, we'll use this. Yeah. System.in.
Okay. Now, if you read this, it's not used. String name equal to scanner dot next. Okay, let me put it this way. Now, if you read this, resource scan is never closed. So what will you do in the finally block? You'll simply close it. Let me put scanner here outside the try block. So here, if you see, I declared scanner inside my try block. So this visibility is only within this try block only. You cannot access it in the finally block. Okay, so what you can do is cut it and put it outside the try block. Now this will be visible. Scanner dot close. Here you won't get any error. So you're going to close all your resources in the finally block. You have something called as an advanced, like you have something called as try with resources block. With that block, by default, whenever the operation is complete, all the resources will be closed. So here you don't have any catch block because it is directly throwing an IO exception. And this doesn't have any finally block because whatever code you put within these brackets, those will be automatically closed. So I have some buffered reader and buffered writer, which are same as my scanner classes. So they should always be closed after the operation. That's why I kept it in this block. When it comes out of the try block, automatically the reader and the writer gets closed. Hence, the need of finally block can be eliminated. So this function is coming from Java 7, like after Java, like from Java 7 and the next versions. You have this try with resources block. Did you understand? Like when to use a normal try catch block and when to use a try with resources block?
Yeah.
Yeah. So in a nutshell, like this piece of code does not require any try with resources block because you're not having any resource here. You're not reading anything from outside, or you're not putting something from a code to outside file to outside of your Java application. So this doesn't require any opening or closing a stream. Whereas buffered reader or buffered writer, these are called your streams. So they're expecting some data outside your Java application, or they'll be writing some data to outside your Java application. Hence, these will come under the streams. So you can put them under the try block and put them in this syntax. It is this syntax. try, provide the resource, close it. That's it. So here it'll provide the resource. So, and you need not have a finally block. So because they'll be like after this operation is complete, this will be automatically closed. You can also write the same code. You can also write it in this format also. Everything is the same. It will generate the same bytecode. One thing is like it will make your code look very cleaner and neater. That's it. Clear?
Yes.
Okay. So this will complete our exception handling also. Unchecked error. Java throws keywords. Okay. Next, let me quickly deep dive into the Java threads. So with the interest of time, like we're just going on basic concepts of threads, like how to create them and how to initialize them. That's it. So like we did not go deeper into them. When you're working with them, you'll get to know. Goes on. Java thread. So now what is a thread? Now let me give a simple example. Take a Gmail application. So within a Gmail, let's say you have thousands and thousands of emails. So whenever you load your application, it is not possible. Like it would be possible, but within the fraction of seconds, you need to get those thousands and thousands of emails for each customer within a fraction of seconds. So what this will do is it will cause a huge load on the servers. So with just one API request, you're going to retrieve thousands, millions and millions records of data, and you're going to load it. So this will cause a huge load, and it will also take a lot of time. So what we can do is split the process into threads. So in Java, a thread means a simple Java process. Take a small process, do some functionality, and return back the response. Then take another process, provide an operation, it will do it, and it will give a response. And the last, simply club them. So
It seems like microservices.
Microservices means each thing, like every module is independently that will be executed independently.
Okay.
Here this is a process. That is a service.
Okay.
Now
Got
you're working on the same application. Like take a simple Gmail application only. Okay, you're working on simple Gmail application. You want 1,000 records of your first email of your email. Okay. And let's say for fetching 1,000 records, the time which it takes is 30 seconds for fetching 1,000 records. Let's say. Now what you can do is within your Java application, you'll put one iterator. Okay, for I equal to 0, I less than or equal to 100, I plus plus, fetch first 100 records. So obviously that will be done in 2 seconds for me. Similarly, I'll spin up one more thread and I'll type for I equal to 100 and I less than or equal to again 200. Spin up a new thread. So now I'll have 5 threads. 5 threads now. 5 threads meaning 5 Java processes. Everything will be executed in the same time. So within same 2 seconds, I'm going to retrieve all the 1,000 records with just 2 seconds, because with a single process, I'm triggering 5 new Java processes. That is called as threading. Multi-threading in Java is a process of executing multiple threads simultaneously.
What can we achieve if we follow multi-threading concept means?
What can you achieve? Like you're trying, like did you like what I explained you regarding the Gmail, right? Did you understand that?
Yeah. Like we can reduce the time
You
as
can
a
reduce, you can
right?
reduce the time, you can reduce the complexity, you can reduce the load on the server. Your application will work
Okay.
faster.
Okay.
Yeah.
For
So
better code efficiency, right?
yeah, for better, like if you have large operations to do, simply put in multi-threading. Let's say if you want to print 1,000, like you have a printer. You
Uh-huh.
want to print full 1,000 records. Each record is having some 100 pages. Long process, right?
Okay.
Put it in a thread. Simply put them in a thread. One thread will be executing, next thread will be executing. Whenever it gets a feedback from the first thread, take the second thread and execute it.
Okay.
Yeah, like complex operations, big operations, whatever are the time-consuming operations. If you put them into threads, right? So within the same amount of time, those many Java processes will be independently working, and they'll give you response. You take the response, club it, and simply show it.
Okay.
Now, like you can let me show. I have like now. Let's say if I have these many, right? Like 360 mails. Like let's say if I have these, like I'm having these many mails. If I simply refresh them, I'll get I need to get all the 360 records. Like that mails will have images, links, everything. So that's a huge bulk content, which can be of size anything. So this bulk content is stored in the server. You need to make a request, get the content, and then load it on my page within a single click. So and the response time should be again like right, like whenever you're trying to access something, the maximum response time should be 2 seconds. And that means your API should there are multiple APIs which are running behind. Those should give you a response time within milliseconds. Only then the end customer will be happy. Imagine just for getting 300 emails within your Gmail, you wait for 2 minutes. There's no use. So whenever you click on your Gmail, there'll be one method. That method will simultaneously trigger 10 other methods, 10 other threads. Each thread will trigger, give you some response. And within that 2 seconds only, you're going to display all the responses. Done, right?
Yeah.
Yeah, this is not a real world example because Gmail is constructed in a different way. I'm just giving you like for these type of operations.
Okay.
For these type of operations, you can make use of this multi-threading concept.
Okay.
I heard another voice. Okay. So a thread is a lightweight subprocess, the smallest unit of processing. So multiprocessing and multithreading both are used to achieve multitasking. So it is the smallest independent unit of a program. So it is also a program, and they run independently. Contains separate path of execution. So every Java program contains at least one thread. We know that thread means a process. So for Java application to run, it needs to have at least one process. That's why every Java program contains at least one thread. Threads are created and controlled by the java.lang.thread class. So whatever concepts which you're going to learn, everything will be created from this package only, java.lang.thread class package. Advantages: it doesn't block the user because the threads are independent. You can perform multiple operations at the same time, at same instant of time. So you can perform many operations together, so it saves time. Threads are independent, so it doesn't affect other threads, and if an exception occurs in a single thread, so you have 10 threads, and if the second thread is having some exception, the third thread won't be affected because they're independent. Whenever you just trigger that method, all the threads will be executed. If there's any exception, the thread will be in hanging state. So you have 5 life cycles. So like if you take let's say you take a car. What is the life cycle of a car? It can be in park state, parked, PRKD. It can be in park state. Like when you turn on the engine, it is in starting stage. When you just gear it up and you start moving, it is in running state. If you stop, it is stop state. And again, if you just shut down the engine and put it somewhere, then again it goes to the park state. So if you take a simple car, it has 4 states, ideally. Similarly, thread also has some states. So the first state is new. So whenever a thread is created, that is always in new state. And whenever you invoke the thread, meaning if you call the thread using some method, like how you start a car with a key, you'll start a thread with this method, start method. Then the thread will change to active state. From new, it will go to active. And next, blocked or waiting. So whenever a thread is inactive, then the thread is in block state or in waiting state. Thread can be inactive for multiple reasons. So within your thread, let's say if you have a database operation and if your database is not giving you any data, what the thread will do, it doesn't know what to do. It simply stay there. Okay, so that state can be set as blocked or waiting state. Next is timed waiting. Timed waiting means we know that two threads are independent, but you can write a code such that if above thread is executed, start the below thread. You can write that custom code. So let's say now if thread A completes, start thread B. Now let's thread A is taking some time to complete. Until that A is complete, thread B will not start. So what thread B will think is it will wait, and you know the meaning of starvation, right? Waiting for something. Like you starve for food. If there's no food, right, you just wait for some food and you starve for food. Similarly, thread B will be starving for A. So what you can do is you can provide thread a waiting state, telling that okay, thread A has some operation which will take some time, hence you please go into waiting state. That is called as timed waiting. Meaning you're telling the thread B to wait for some time until thread A is executed, instead of thread B waiting for thread A to complete. Making sense? Thread B is not waiting for thread A to complete. You are telling thread B to wait till thread A is complete by providing some time. That is called as timed waiting. Is this clear? Because this is most important. Timed waiting. Yes, no. It might be confusing now, but like okay, when you're doing the actual coding part, I think that would be clear.
Okay.
Yeah. Okay. Is it is the theoretical concept clear? What is timed waiting?
Yeah.
Okay. The last state is terminated state. So once the thread execution is complete, right, it simply goes in termination state. So these are 5 states. Okay. New, active, blocked or waiting, timed waiting, and terminated. 5 states. How to create a thread? It can be created in 2 ways. You have the thread class. Thread class means java.lang.thread. That's the class. With that, you can create a new thread, or you can use something called as a runnable interface. So you'll create a class and you simply implement the runnable interface. Then you can create a thread. Let me quickly show you them. Now see, I have something called this is a class. This is my main method. How can you create a just a minute? How can you create a thread? By the thread class. So if you see thread, so this thread is coming from java.lang.thread. So this is the class. Thread t equal to new thread tetra. And to start this, now t is called a thread. To start this, you need to simply invoke this method t.start. Same like your how you key in your car engine and just start it. To start a thread, you need to have something called as a start method. Start method. So if you type t.start, this thread will be started. And see that start is a method. Okay. So since t is a thread, t dot since now how can like you might get a doubt that how come like is T really a thread or not? So if we just type T dot, then you'll get the methods also. Start coming from thread class, stop coming from thread class. Now let me print this. Etc. So if you open the thread, allocates a new thread object, the constructor has the same effect as thread null name. So so what is my constructor doing? I'm simply passing a name here of type string. So when I start the thread, T thread will be created with name called tetra. So if I want to know the name of my thread, and my this tetra is in string, right? So I'll simply put string str equal to t.getName, and if I print the str, I'm going to get it. I'm going to get the name of the thread this way. You can also, I'll tell you this, t dot get state syso. And let me put here also, and let me put here also. T dot get state means I'm trying to get the state of my thread. It can be in any one of the five. Now see, initially my thread state is set, my thread state is new. That means I just created a new thread. After that, it went into runnable state, meaning once I started my thread using the thread.start method, it changed to runnable. Okay, now let me stop it. T dot deprecated. That's fine. Deprecated. That's fine. Let me remove this. Yeah, it went into runnable state, and then whatever is the thread name, I'm just printing it. So this is how you just create a simple thread. Let me create a multiple thread now. Now, the main difference between my custom thread and I'll just explain this one concept and I'll conclude the class. Okay. If you see my custom thread class, I created a thread using the thread keyword, thread t equal to new thread. But here, if you see my multi.java class, my multi.java class is extending the thread class, meaning so multi is a thread. That's the meaning. Extends means is a relationship. So multi is a thread. So I need not use a thread keyword here because I'm extending the thread class. My multi class can be directly used as a thread class. So multi m equal to new multi and m dot start. I can trigger this. So creation of a thread in many ways. You can use a thread keyword, or you can create a class by extending the thread class. And here, if you see, this is two ways. Multi-run m1 equal to new multi-run, and thread t equal to new thread, and you're passing multi-run as the what you call the parameter within a constructor. Now, if you see the class, this is implementing here runnable. Runnable is an interface. So when we discussed that threads can be created in two ways, using the thread class and using the runnable interface. So if you want to do something with the interface, you need to implement it. So write a class name using implements keyword, implement the interface. So if I don't have this, I'll get an error. because interface is a class which has abstract methods. So they have only functionalities, no implementations. So here, now if I implement the runnable interface, and if I don't have a run method, it will show me the error. And the type multirun must implement something. So if I type this, I'll get it. So if I'm implementing something called as a runnable interface, I need to have a run method. That is for sure. I need to have it. And type your own my thread. Okay, I just put as my thread. Now multirun m1 equal to new multirun, thread t1 equal to new thread. Pass the m1 object within this, and just type t1 dot start. So this will in turn trigger my run method. Java application, my thread. So you can create threads in two ways, using the Java thread class and also the runnable interface. Clear?
Yeah.
Yeah. So tomorrow I'm going to cover the remaining things also. The thread pull, thread sleep within just 15 minutes, and at 5:30, let's start the Spring Boot.
This threading concept seems like complex compared to exception handling.